Let's try. Cool. This is what I see. Will my slides be visible? Will slides be visible? It depends on Zoom.
You need to share it, or else we can make the camera to focus on the slide as well as the presenter. How many presenters are there?
Yeah, at one time, just one presenter.
Yeah, we can make it to focus on you and the slide together.
Yeah, that's cool. That's cool. So it works. Hello, guys. Not a lot of people, but 38 are applied. It's interesting. You're not, as I see, there are not 38 people. We can wait a couple minutes, yeah, and then we start, or 5 minutes. By the way, you can share the link to YouTube. Daniel added a link to YouTube as a live streaming to the comments on meetup.com, so you can share with your friends, of course.
Раз.
All right, let's start. Hello, everyone. Welcome on MENA Mobile Meetup. So we're trying to, with my friend Daniel, we're making this meetup. We're hosting this meetup, and we are the first speakers on this meetup. So probably we will make it regular. Maybe not. We will try. Maybe we'll do it unregular, but it's the first one. So looks like it will. There will be the second and maybe the third, and let's see. Let's see how it will go. What we will talk about today? We will talk about some Android internal thing and about Jetpack Compose. About how to make a design system on Jetpack Compose. And the first speech will be from me. My name is Anton Dudakov. I'm software engineer in Xena. On my next slide, I will talk about, I will say a couple of words about Xena, but what I'm doing now. Previously, I was working in Sberbank in devices department, where I was responsible for system software for devices. Sberbank is the biggest Russian bank, and as I remember, biggest in the Western Union. Sounds interesting. In the Western Europe bank. And before Sberbank, I was working in Yandex in automotive department, where I was responsible for making devices, for software for devices. So all the devices are based on Android. So I know deeply how Android works inside because I had some experience with it. And also, I'm a part of Russian podcast, of Android Dev Podcast. It's the first Russian Android podcast. And what is Xena? In Xena, we're making the app that can replace cash. It's not just an app; it's a system. It's a financial freedom for this region, and it's already alive. You can download it from App Store, and it will be available for download in Google Play very, very soon. So stay tuned. All right, let's go. I called my speech "How Android apps talk to each other." So actually, the speech is about inter-process communication, because different apps, probably you have different apps, probably have different processes in one app, and you need to handle with it somehow. You need to call some functions from one process to another. And but actually, you cannot just call the function from one process to another just directly. No, because you live in different parts of memory of the operating system, and you cannot just share some data in RAM or somehow else the fast way. So you need to find something to get the communication between apps. And what IPC can offer for you? IPC gives you a way how to call the functions, how to share data, how to run another app and get the result. But how they work internally, I will talk about it. What API Android can offer for you? Of course, you can use not only Android API, you can use some some another API, some Linux API. You can use files, or you can use your backend to share data and call functions from one application to another. But we'll talk about Android and about its internals. There are some ways, and we will talk about each of these option, how to deal with IPC. But before we go further, what is under the hood? In every IPC call, everything works through the binder. In Android, everything works through the binder. Binder, it looks like a device in Linux system. So it is in devices folder. So it looks like a device, but actually it's a driver. It's a software. It's a software which provides the communication between processes. To go from one process to another, you need to go through the binder. You need to connect to binder, and binder will handle it, and will send your data or your call to another process. You cannot do it directly, only through the binder. And the first type is very, very, very simple way. I believe all of you one day try this, and I believe many of you have a lot of wrote already a lot of code with these lines, with lines like this. So just start one activity from another. Only 3 lines of code, and they can be even less. There can be only 2 lines of code. Very simple, very simple. Run, and it call this, and it runs another app, another activity. But under the hood, under this simplicity, how does it work? Actually, it works something like this. From your activity, from your application, you call start activity for result. And this call goes to the activity manager service. It's a service, and it's a service in the operating system, and it works in the system process. So your call goes to this process and asks activity manager to start the app. Activity manager finds the proper activity and starts this activity. Then activity works, finishes, sets the result, and then it finishes. And then activity manager just returns you the result of this activity. But as I said, activity manager works in separate process. And this schema will show you how it works between the processes. Actually, you cannot just call the activity manager service from your process. As I said, you cannot just call directly the function from one app in another. And these are different apps, actually. Your app and the system process. It's different apps, different processes, and you cannot call. And it works, but you have in your app, in the context, you already have activity manager proxy. And this proxy handles all your calls. When you call start activity for result, it actually from context goes to the activity manager proxy. Then this proxy calls activity manager stop through the binder in the system process. It goes through the binder to activity manager stop. And this activity manager stop, this class already calls start activity on activity manager service because it's already in the system process. And then activity manager service finds the proper application, starts this application, and then when application started, it gives to the activity manager service through its proxy. It gives the application itself, the application's proxy, and then activity manager service can call launch activity when it already has a link to the activity. Everything goes through the binder, not directly through the binder. On the next slide, I will show how. Then activity works, then it finishes and says the result. Once it finished, the call about the activity finished goes to the activity manager service. through the binder to activity manager stub at first, and then activity manager stub calls activity manager service, and then activity manager service returns the call to the first application, to the first process through the binder to the application stub, and then activity gets the result. But you can ask, where's the binder here? It's in the middle. It's in the middle between the processes. There is a binder. How does it work in the binder? As I said, for application number one, first application or your application, sometimes I will say your application, sometimes I will say application number one or first application. Yeah, it's the same. Your application already has activity manager proxy with the binder link inside. And when you call start activity for result, actually activity manager proxy runs a transaction on the binder device. As I said, it's not actually a device, it's a driver, and actually it's a software. It runs a transaction on a binder on the software, transaction number something, on the description number, no, description something. Description is a string, transaction is a number. And binder already knows which process has which descriptor. And it runs on the proper descriptor, it runs a transaction. Activity manager stub already has a connection, also has a connection with the binder, with its descriptor. And this is how it finds what transaction to run. When activity manager stub receives a call from a binder, just on transaction, it runs a transaction, and it determines what transaction means what. So when it receives run transaction number J, call start activity with these params, and it starts an activity, and it calls the activity manager service with the start activity. And the opposite is very, very similar. Activity manager service already has applications proxy, because when it starts the process, application sends its proxy to its binder to the activity manager service. So activity manager service already has applications proxy with a binder inside it, and application proxy calls a transaction. Very, very similar, absolutely similar, or we can say same. It runs a transaction, binder driver finds a proper descriptor and runs a transaction on it, and voila, you receive on activity result in your activity. And the whole schema works like this. So this is the whole schema with the connector to binder and forward and backward with the result, with everything. So you start activity, it goes through the activity manager proxy, through the driver to activity manager service. It starts the process, and then it schedules launch activity. Activity works, and back through the binder driver to the activity manager service, through the binder driver to first activity, the result. This is how it works. But sometimes you can see this thing. You can see a transaction to large exception. Why it happens? Because every time when a new process is created, it created with some amount of memory for the binder. So how much memory it can transfer through the binder. And actually, when you open process state.cpp file in Android sources, you can find this line. It's the binder driver already defined. It's 1 megabyte minus something. Actually, minus in previous versions it was 4 kilobytes. So it's 1 megabyte minus 4 kilobytes. But in current version, it's just configured somewhere in the system. But anyway, it's around same size. Of course, devices manufacturers can define different amount of data, but you need to it will be not it probably they may define, but they don't do it, because you should rely on 1 megabyte. You should just keep it in mind that it's around 1 megabyte, not more than. And yeah, the limitations, as I said, it's 1 megabyte per transaction, even less, of course. And of course, when you launch another app in another process, the system, the user will leave your app, and the system can kill your app. You just should prepare. You should be prepared for this, and you can share the data that you can put to the bundle. It's primitives, strings, serializables, parsellables, and list of these classes. And the main purpose, it's obvious: start activity for result, or start activity you should use for starting activity, of course. Next, send broadcast. Actually, 3 lines of code. Oh, 4. But actually, it can be 2, of course. Very, very similar. Just a couple lines of code to send a broadcast. But inside, it's something interesting. It's a little different than start activity, but the binder works in the same way. When you launch send broadcast, this call goes launches on Activity Manager proxy. It goes through the binder to Activity Manager stub, and then it goes to the Activity Manager stub calls the method of the Activity Manager service. And what it does, Activity Manager service actually does not do at the same time when you send a broadcast. It puts the intent to the queue. It has a couple queues. I will talk on the next slide about the queues, but it puts the intent to the queue and delivers it sequentially from one app to another. Once first app got the intent, and once it finishes receiving it, finish the call on receive, Activity Manager service starts delivering to next app, and then it loops the queue. And what are the queues? Actually, it's written 3 queues here, but actually there are 5 queues. But you should think that there is only 1 queue, and there is a reason, because sticky broadcasts are deprecated, and each of these 2 queues has 2 more queues inside it for ordered broadcasts and unordered. But mostly, so foreground broadcast, if you add a flag that to intent that it should be foreground broadcast, then the app that receives a broadcast will launch with a foreground priority for, of course, for not a big amount of time, but it will have a priority of foreground. And background it's just a broadcast. But as I said, you should think that there is only 1 queue in the system for the performance reason, because all the apps use same queues. If there is 100 apps that sends 100 broadcasts, there will be a lot of broadcasts in 1 queue, or even in 2. Doesn't matter. And when the receiver apps starts serving this, start receiving this broadcast, the system will deliver them one by one to each app, each broadcast, and all of them will be sequentially. And you need to remember that it can take a long time to deliver a broadcast. When I say long time, it's really long time. It can be more than a minute, because if there are a lot of broadcasts in the system still will work sequentially. Yeah, and these are limitations, of course. Same limitations as for activity about what data can we share, and same about the size, 1 megabyte, because it goes through the binder also. So this is why we have a limitation of 1 megabyte and the data. And of course, the time of delivering, as I said, is not guaranteed. It's fully asynchronous. Nothing guaranteed for you. So better. It's better to think that there is one queue and you can slow down the whole system if you plan to send a lot of broadcast. And when it's fine to use broadcast, of course, when you want to receive some notifications from system, there's nothing to do with it. You can only use broadcast. And when you not care about the delivering time, you can use it. But as I said, don't use it a lot because you can slow down the whole system. The next part, AIDL. This is a more custom way to make RPC. This is how it works. This is how you can get your own stub and proxy and go through the binder from one app to another and call functions from one app to another. This and how it works. Yeah, couple lines of code. On the client, you need to create a service connection and bind to the service. And when you bound to the service, you will receive a callback to your service connection with binder of this service. And then you can have you can create a connection. You can have a connection with the service and call methods like it's in your own process, but they will go through the binder, of course. So there are a couple classes. On the server, you need to implement stub, and this will be your binder, and the calls will go to the stub. And yeah, as I said, on the client, you will receive the binder, and you will have a connection with the server through the binder that you received. The binder, actually it's like a reference to the remote service. How to get these stubs and how to get this method as interface? You need to declare the files, AIDL files. You need to declare on the server side, actually both client and server need to have these files to connect to each other. You need to declare an interface for the service, and you need to declare some data if you want to share some data. And the system will generate stubs for you, and you will just need to implement the stub. And because it's abstract classes, and you will need to implement the functions of these abstract classes. How does it work? As I said, everything works through the binder. On your context, as it was in the code, you create a service connection, and you pass this service connection to Activity Manager, and you call bind service. Activity Manager finds the proper application and starts service in this application. Then service creates its stub. And after stub is created, service passes a binder, actually a proxy, to the service connection. And then when you have a proxy, you can call methods on this proxy. You can get data or set data or just call some methods, everything you want, almost everything. And there are same types of data that you can share. Very similar to, because it works through the binder, it supports all the types of data that binder supports. And of course, you can pass your custom objects when they are parsable. Yeah, and one more thing, there is I interface. I interface is actually the the interface of some object that you can pass. You can pass object with methods, a callbacks, and how to declare callbacks. When you want remote service call your functions, you can declare a callback. It's just one more AIDL file, one more interface, very similar like we did for the service. It's just a callback. You just declare a callback like simple interface, and you add this callback as a function as a function parameter in the service, and then you can pass it. That's all. Of course, you need to declare this callback. The system will generate for you the stub, and you need to implement this abstract class, this stub, and then you can pass it to the service, and then service can call functions of your interface on your object. Everything works through the binder, as I said. You create the service connection, you pass the service connection to the service. Service creates its own stub. It passes you a proxy, and then you can call on this proxy. You call set callback. The service receives the callback, and service can call functions of your callback through the binder. Of course, there is something in Android SDK, in Android system. There is an object called messenger. This is if you don't want to write your own callback, you can use messenger. It's just an object. It's parsable object with methods that you can pass instead of creating your own callbacks. And you can send through the object some data. You can send a bundle through this messenger object. Just create a messenger, pass it to the service, and then service will send you some data through this messenger messages, of course. When it's good to use AIDL? Actually, there is a lot of cases when to use AIDL, because it's every time when you need an inter-process communication, you can use AIDL almost every time, except some special cases we will talk about a little later. Yeah, you can call synchronous methods, you can call asynchronous method, but you just need to understand when you call bind service, you will get the callback asynchronously. You will receive the service connection asynchronously. There are some tricks how to make it synchronous on the main thread, but it can be a topic for another speech. Yeah. You can use it, as I said, many things. And the limitations on object size is the same, because it works through the binder. It has the limitation of 1 megabyte, minus 4 kilobyte. More interesting thing, content provider. Actually, there are a little more lines of code than just starting an activity or sending broadcast. And they're a little different, and it works a little different, a little similar, but a little different. First, you need to get a content resolver and run the query on it. Then you will receive a cursor, and then you iterate through the cursor and get the data from this cursor. On the server side, you just create a cursor and return it to the caller. And how it works? Through the binder, of course. As I said, everything works through the binder. First, you want to run a query. You run this query on the content resolver, and content resolver goes to activity manager and finds the proper content provider proxy. Then you receive a content provider proxy. You already heard it about proxies and stubs. And when you have a content provider proxy, you can call the query on this proxy through the binder directly, without activity manager. Activity manager just need to find it. And you run this query, and this query goes through the binder to the content provider stub, of course, but you already know about it. This is why I don't show it on this slide. And content providers runs when you create a cursor and give a cursor back. Actually, content provider creates a bulk cursor. Doesn't matter which cursor do you use. Do you create a matrix cursor, as I did in my example, or do you create or do you get a cursor from a database? Doesn't matter. Content provider always creates bulk cursor. And then it returns you a cursor proxy. Of course, proxies, stubs, binder, everything works like this. And then when you start iterating through the cursor, you call move to first. And this call goes through the binder proxy to the through the bulk cursor proxy to the bulk cursor, and it moves to the first, this cursor. What's next? Bulk cursor creates a new cursor window, and this is a parsable object. And this parsable objects creates some block of data, 2 megabytes of data. I think you already you remember that I've said that everything works through the binder. Not everything actually. This thing works not through the binder, but through the ASHMEM, asynchronous shared memory. It's a Linux mechanism to share some data between apps. So the cursor window creates the block of data of 2 megabytes of data in the anonymous shared memory. It's a Linux mechanism, as I said, and it fills it with the data, with the binary data. And then you receive this cursor window, which I said it's a parsable object. Then it goes easier through the binder, and it has a reference, a parsable reference to the block of data. And then the cursor window that you already have, it filled with a block of data from this block, with that data that was shared with the cursor window on the by the application 2, not your is application 1. This is how it works. Not through the binder actually, but through the Linux mechanism. And actually, there is a limitation of 2 megabytes per line, but you can have as much lines as you need. But each line should be 2 megabytes because of the limitation, because it creates 2 megabytes of data. It's configured in the Android. You can share actually some primitives and some bytes or some binary data actually, and it was created to share the data, of course, to share structured data from the database or something like this. Actually, there is some more thing in the content provider. There is a method call in the content provider. Actually, instead of calling query, you can call on the content provider and get the bundle. And this is a synchronous method. And actually, you can use this instead of creating AIDL service. In this case, you will not need to create a service, and this will be just directly without waiting a service connection, and you can just call it. There is one more interesting thing in the content provider. There is ability to share data, to share files through the content provider without permissions, without getting permissions to the files. Between two apps, between two processes, share just a stream of data. There is a method in the content provider, it's called open file. You just override it and pass some stream. Actually, to pass a stream, you need to create a pipe. The call create pipe. It's a static method in the content provider, and inside it creates a pipe with help of operating system API. And you receive two file with when call this method. When you call this method, you will receive two file descriptors, one for reading and another one for writing. You can pass any any of this descriptor to the caller. But in this example, I'm passing the reading descriptor, and I'm creating the new thread, and I start writing to the write descriptor. Yeah, I return a read descriptor. And start write to write descriptor, of course. On the client side, you receive the descriptor and you start read from it. And that's all. And then you close it. How it works inside. Something similar, something not. Actually, you get the file descriptor through the binder. Then content provider creates pipe and starts write data to this pipe. It returns you read descriptor, and you start read the data from this pipe. And yeah, this is how you can get the stream of data from the content provider. Too long animation. Okay. So that's it. That's all. What else? There is some special API in Android to share data to make a connection between apps. Of course, there is account manager to share some data about your accounts with the other apps on get from other some data from other apps to share and to get. Of course, there is app widgets. When you start developing for Android, you probably, like me, chose this operating system because of widgets. iOS didn't have it at that time. But yeah, you can create your own launcher, and you can implement a widget host and show the UI of other apps on your widget host. Show the widgets, remote views. And there's also one more thing. You can listen all the notification that other apps sends, and you can listen them from the by extending from notification listening service. But there's not a simple. It's not as simple to get the permission for this. You can open special permissions activity for the user and ask the user, please give us a permission. Go to this screen and put this check mark. It's really, it's not easy, but you need it. Actually, smartwatches, Android Auto uses this mechanism to show the notifications for you on watches or in the car or somewhere, maybe something else. And one more thing that actually you need to implement notification listener service to use it. Because it works through the notification mechanism. Media session on the modern Android and old Android was using remote controller. It's a mechanism to control media apps. So to start playing, to control the playback, to choose the track. Actually, many things uses this mechanism. Of course, Android Auto in cars, of course, smartwatches, and Bluetooth mechanism also uses this thing to show the choosing the track. It also Bluetooth mechanism also uses media session. I can talk a lot about media sessions, but it can be in another speech. Yeah, and what we have. I hope after this speech, you will it was useful, and you will use the proper methods to make an IPC in proper cases. So please choose the correct ones when you need something special or not even special. Thank you very much. There are my contacts, and if you have any questions, Daniel will give you a mic, and yeah, you can ask. And we have some presents for best questions. Yeah, so this is also work for me. I will I will have to remember all of them. Any questions? Talal, you have a question? Yeah. After they ask the questions, I will not say about it. If there will be no questions, I will not say what Talal says me. Any? At least one? No? Was it boring? Did you like it? Was it boring? Okay. Talal says me that there is a pizza behind you. And yeah, what about our Z fridge? Does it work? Yeah, cool. So there is a pizza and there is a lemonade. We built it on our own, in the lemonade in our own vending machine. It's really cheap. Don't worry about it. We built it on our own technologies of Zina. And if you still have questions, if you have questions, but you don't want to ask them publicly, you can ask them personally while we will switch in the slides. And Daniel, please prepare for your speech. And yeah, thank you very much. Let's do a break, couple minutes while Daniel switches, and you can get pizza, or you can buy lemonade. Yeah, let's do a break. Let's say 5 minutes. We have time. Yeah, yeah, we have. Thank you.
1, 2. Yeah.
And my? Yeah. We'll continue. Please welcome Daniel Serdukov, our next speaker.
Yeah. Hey, guys. My speech is not going to be as fundamental as Anton's. Yeah. I'm going to tell you about how to colorize buttons. Don't be shy. We all do this. Yeah. Seriously, we're going to talking about how to build a design system in a Jetpack Compose. Well, first of all, yeah, let me start from introducing myself. So my name is Daniel. I'm working in Karim. I guess the company does not need introduction. Yeah, well, let's begin. How to actually build a design system with a Jetpack Compose? The first, you may think it's, why do we actually need it, right? There is a material design, right? Just use it and everything will good. Yes, it is, but it may work or may not. I don't know. I guess nobody does, because I'm pretty sure that nobody's started to build the apps from scratch with the Compose and material design. So yeah, it may work perfectly well if you're trying to develop everything from scratch using Compose and material design, right? But if you have pretty huge code base with a tons of UI, different teams, different apps, so it might be, painful to create a consistent UI. So why do we at Karim need it actually, right? Before become the region first super app, right? The Karim used to be a bunch of smaller apps. By the smaller, I mean, there were standalone apps published in the Google Play, but there were the several apps like a food, ride, delivery. And each of these mini app, how we call them now, but each of this app, I would like to tell had, but still has its own set of resources. Yeah, its own set of resources. Even more, much of those resources are duplicated across the apps, right? Because, you know, the brand, so we have to use some style and some resources in there. And we have a pair up re-implementation of some functionality. And by re-implementation, I literally mean re-implementation, not just a copy paste, right? So there's some logic re-implemented in different apps differently. So we're getting the bugs, different bugs for the same functionality. And there is a brand, there is a style, but there is no consistency in our UI and UX. So the first idea, what can be a solution for this one? Well, the first idea that came into the mind, so move everything into the shared library, and that's it. Everything should work. Just add the dependency to the shared library, and everything will be good. Yeah, but it is a partial solution. First of all, because the release process, you know, this library should be the project by its own, right? So it should have this own its own release cycle, review process, and so on. So if you want to make a change, so you have to go through this process, release the new version, update the dependency in your app, and then you will get the result. But we all faced the issue, right? So the deadline was yesterday, and yeah, you know, there's always no time to do all these things, and release train should go. And fighting inner demons, right? So you make a decision to fix everything in place or make a change in place inside of app. You may even put the to-do, right? That this functionality should be refactored someday in the future, but this to-do, I'm pretty sure, gonna live forever. Yeah, so how are we gonna to solve this problem? Well, we're going to do it heroically by introducing design system. Well, what is design system actually is? It is a shared library. Yes, it is. But in addition, it is a contract between all participants, right? So all sides. And this contract should be followed by all of us. But let's start with the overview of the material design system, since we're talking about the design system, right? So let's start with the very beginning. So this is how the material design system looks like. So it's based on the schemas or materials, how Google calls them, right? So this schemas is like a color schema, typography schema, shape schema, and all of the schemas provides you with the actual values for color, text style, and shape. But pay attention. So material design does not operate with real values or real names for color, for example, right? So you won't get the black, purple, blue, and so on. So you can just use the primary, secondary, surface, background, etc. So this is the great way because you can change the color internally inside of your material, inside of your design system, right? Without touching the code of the apps. But it creates some problems, right? So we already have everything from the first view, right? But you know, designers, they always need more colors, more fonts, more sizes, more everything. So yeah, material design is not enough for us. This is our color palette. And as you may notice, there are more than 12 colors in there, but why 12? Because the material design provides us with the 12 aliases for colors. And if you need more, so you have to create your own. And this is what we are actually going to do, right? So we're going to create our own design system. But first of all, we have to, write down or declare some principles and restrictions. So first of all, do not expose the real values as material does, and which is great. But do not exposing real values. I mean, so do not give the developers real colors or color values like a gray, green, purple, orange. Just use the aliases for them, or how the Anton tell me. So the meaningful name is a good good name for the aliases, right? So here is the text colors, for example. So we have 7 text colors. Yeah, and by using these meaningful names, right? So you can even guess where you can see these colors, right? So for example, primary color, when you see the primary color, you can guess that it's the color for the 90% of your content, right? Same as the secondary. So you can even guess that it's somewhere inside of the list cell. Okay. And the second one, it's do not expose the instantiable, copyable, mutable, or any mutable structures or framework classes. What does it mean? So it means that, for example, if you have some fancy content, right, and you're going to use some text inside, so this is the right example how you should use the colors from the material team or typography. But what prevents us from doing that one? This one, right? So we can use any color we want outside of material team scope, or even create our own color, right? Or we can create the new typography by overriding some attributes inside, right? Because you can get the specification from the designers. And what we actually want to achieve, we want to achieve this one without any possibilities to create the new colors or new typography or any other attribute. How can we achieve that? Well, we can do it by declaring our own structures for all attributes, right? So here we are using pretty lightweight value classes, which is just a wrapper around the compose color, right? And that's it. By doing that, we are getting the strong typing, right? So if someone of your colleagues or even you gonna use another color, right, or which is not declared in the design system, so you won't be able to do this because of strong typing. Even more, this way is the backward compatible. You may have the pretty custom UI, right, pretty custom widget, which is rely on color and style and any other attribute. And we can use the attributes declared in the theme, right? In the design system by unwrapping them into the compose values, right? Into Jetpack values. So this way, this works for both worlds, right? When you are using design system and where you have to use the custom UI you already have. Okay, before we go deeper, let's talk about how can you pass data to the composable functions, right? So just imagine you need to pass the state data to the green blocks, right? By default, right? So you can pass the data through the whole chain as a function parameter, right? But it kind of mess, right? And the Google provides us with the composition locals. It is a functionality that allow us to create some kind of, not a global object, but the scoped object. And you can get the data directly from the composition local provider inside of your green blocks. But there is a difference of the global object, right? The composition locals is scoped, which means that you can declare the composition local in some subtree of your UI, right? And the data will be available only from the subtree underneath of your declaration. Okay, so this allows us to get the values from any composable functions without passing the data directly through the chain. Okay, so here is I hope you can see the code. Yeah, so here is the main function of the whole design system. It is a theme. By the way, Aurora, it is a name of our design system. So the Aurora theme, it is I would say that the main entry point, right, of our design system. And as you can see here, right, our content lies at the very bottom. So it is a leaf node of our tree, which allows us to resolve all attributes declared above. Even more, for example, we can get the attribute on level above, right? This one, because the local text colors in this case, right, they're declared in the ancestor node. If you'll try to get to resolve the attribute on the same level, so you may get an error. Well, it depends, but usually yes, you can get an error. Okay, now we have the global overview, how the design system should look like and what is the entry point. Let's have a look on some components, right? So here is the label. Again, you might ask, so are we gonna implement re-implement all components from the material design or from the Compose core? Yes, we are. It is fun, actually. Yeah, so here is the label, which is, just a text. The most useful component in every app. It's pretty straightforward, right? So under the hood, we're using material text, but instead of using the style and color for text, we're using our own attributes like a typography and text color. By the way, you may think a little bit about why we do not use the composition locals directly as a default parameter of our composable function. I will return back to this question and we'll answer it a bit later. And instead, we are gonna use this, I would say, dirty hack, right? Okay, so here is the thing. And this is the simple label implementation. But we're gonna do much more. So we're gonna implement even the UI blocks, more complex UI, like a list item, for example, right? So this is the list item implementation. It's also pretty simple in the Compose implementation, right? So it accepts the list of content. Well, it is it gets the best from the functional programming and the objective-oriented programming. So, but the content is just a sealed class, which is the wraparound composable function. And we have the several widgets, I would say, right? Like a subtitle, C++, counter input, and so on. And this way allow us to use the simple and powerful collection operations to filter content, right? Or to check what kind of content do we have. And based on what content do we have, right? What content has been provided by developers to this list item, we can build the different type of list cells, right? And this way allows developers not to think about how to show the data inside of this list item, right? So everything will be done for it. So everything we have to do is just to pass the specific data we need. Okay. Everything, again, looks pretty good if we are talking about Compose, right? But as I said, we have the tons of UI written in XML, right? And how to support the legacy UI now, right? So thanks Google. Google provides us with the abstract compose view. It is a simple class that requires from you to override the composable content function. And as you can see, so inside we are just using our label component, and the rest of the code should be familiar to everyone, right? Because we are just resolving attributes from the XML file and set the internal fields. The only difference is here. So we're exposing some public properties, mutable properties, right? By mutable state of. The difference between this way and the compose way, it's we do not use remember function around the mutable state of, because the view itself stateful, right? So the view, it is a class, right? And we can store the state of it inside. And the remember function for the compose, right, is like a way to simulate the stateful state. Okay, after doing that, you can just put your view inside an XML file, and there is only one problem. So we have to create this wrappers for each component we have inside of our design system, and we actually do it. Okay, let's return back to the label and implementation. And do you know why we are not using the local composition locals inside as the default parameter for our function? Any guess? Yeah. Okay. Yeah, it is because of the backward compatibility. Again, if we have a look back onto the XML view, right? So to be able to use the composable composition local attributes, right? So we have to be somewhere inside of these green blocks underneath the composition local providers, right? Which means that our content should, again, lies inside at the very bottom of our theme, right? Which means if it's not, so we won't be able to resolve those attributes again, which means that we have to, wrap each our component into the Aurora theme, right, to be able to get those attributes, but it's kind of expensive, right? And instead of this, we use this hack, right? We use kind of Aurora scope, which is also a composable function. And everything it does, it just checks that our component or our content has already been wrapped inside of the Aurora theme. Yes, and as I said previously, right? So the composition locals have the hierarchy nature. And once we already wrap everything into the theme, we should not do it again. Yes, it also creates some overhead, like, yeah, here. Each component wrapped into the Aurora scope, and it is create an overhead, right? But it's much less overhead than we would wrap everything into Aurora theme, and it has the more, it's allow us to switch to use their design system less painfully, right, for the developers, because they shouldn't think about how to wrap everything into the theme, or should they do this, or how to use the XML UI inside of composable UI, etc. Right? So this is how we solve this problem. Okay, here is the summary. Right? What is the design system actually is? So it is a first of all contract between all participants. Everybody should follow. Secondly, it is a framework which has the several layers, I would say, right? Like a foundation layer with the typography, colors, elevations, icons, so all foundation attributes. Then components layer, which based on the foundation layer, right, with the simple components like a label, text, link, button, checkbox, etc. And the content, which is a layer with the complex UI blocks like a list item, card item, search field, tabs, etc. And the last but not least, it is the demo app. Well, of course, I'd like to say that we have 100% unit test coverage inside, but we're not yet. Yeah, and but the unit test, it's just for the developers, for the designers. We have a demo app. I hope it'll work. Yeah. So for the designers, we build the demo app. So this app built completely with the design system, right? It provides designers the way to test the components they designed and we implemented, right? So we have the demo app for both iOS and Android. And yeah, so you can see how it works here. Thank you. Any questions?
Don't be shy.
Yeah, don't be shy.
If you have any questions, yeah.
It was much easier to understand.
We have a question.
Anton's. Yeah.
So I have a question regarding the testing for this the compose. So you need to test the compose like as a part of UI testing, okay?
Yes.
So I've noticed that you need to set this tag for each component to get the view. Like for example, to test it in Espresso, you need to get a view.
Mm-hmm.
And how to get the view? Like for Compose, there is no IDs.
Yes, Compose does not operate with ID. It operates with the semantics, which is the functionality provided by the framework exactly for the unit testing and accessibility ways, accessibility functionality, right? So, and in addition to that, Google provides us with the specific libraries to test Compose with composable UI. So you should not get the view as a view, so you can test it using the semantics matcher, right?
Yeah, so mainly we've seen that the people are using the content description for each, like as you said, the accessibility part.
Yes, but it's a bit different. So content description needs to provide only accessibility feature, right? For the for the screen readers or something like that. But there is also a semantic modifier inside. So just imagine that you have, for example, the text or button or something like that. So you should not provide the content description for that, right? So instead, you can provide the semantic text modifier, or if you not, so the framework does it internally, right? So it uses the text on the button or text on the text, right, as a semantic modifier, right? So, and you can just find the view by the content in it.
Okay, thanks.
Who else?
So my question is related to how do you ship this kind of libraries? How do you share across your various teams, various squads or tribes? Like for example, one of the ways is using Git submodules or and another way is hosting it onto the some Nexus repository artifactory, like a JFrog or Sonatype.
Yeah,
So how do you prefer to like such kind of libraries to do that?
Yes, yeah. We're using the binary distribution, right? So again, as I said, the design system, it is a project on its own, right? So you have to walk through the release process, but in difference between the shared library, just a library, and the design system, right? So there is first of all, the strong typing in there, right? So you cannot just add more colors or more attributes in there. So you have to create the pull request if you need something new inside of the design system. And then yes, everything rest of the same as for the shared library, right? So you have to walk through the release process, update the dependency in your app, and so on.
So you're managing the versioning and also throughout the process, right?
Yeah. Yes.
Okay. Thank you.
Yeah, of course. Maybe the mono repository would be a solution for this problem, but we don't have the mono repository, and probably we're not going to have it. Yeah.
If you have it there, it will be easier to break the rules. But as I understand,
it will
you
be
guys
easier to
just
break the rules.
made things hard to break the rules.
Yeah.
Impossible to break the rules. You made the rule that other developers just cannot break, and even designers cannot break these rules.
So the main purpose of using the design system is not only providing the developers shared library, right, to use the design, to use some UI blocks inside, right, but for the designers too. So they have to use the same, they have to obey the same rules, right? So in Figma, right, files, our designers uses the Figma for the design, right? So in Figma files, so they not operate with the real values for the colors, for example, or hex codes for colors or names for colors. So they operate with the design tokens, how they call them. So like aliases to colors, aliases to fonts, and so on.
Actually, I have. If someone has a question, please say or raise your hand.
Say now.
Not raise. Another word.
Come again?
Yeah. raise your hand. And if not, I'll ask my question, and you can think about your questions. Actually, you said the compositions local. The advantage of composition local that they are scoped, and you can pass them where you want.
Yes.
But actually, do you want?
Yes, you do actually. Yes, you do actually. So
where you use this advantage? Because I just think you need all of them and everywhere. You don't have a place where you just don't want to have them. You have to. I don't think I haven't seen the place where you want to deny some of them, because you everywhere want to have colors. You everywhere want to have fonts and etc. No?
Yes, but in some places you need to override the default values. Like for example, on some of UI blocks, we use the secondary color, the global secondary color as a primary content color, right? And underneath of this subtree, so we use it everywhere. So you can just override this composition local provider, right? And you can override the local content color with a secondary color instead of primary, right? And everything underneath of this declaration, right? So we'll have the secondary color. We'll use the secondary color as a primary content color, right? So only for these cases.
Actually, my friends, we have time for questions and for some discussion, and you are able to ask anything you want, anything you're interested in. Maybe you have questions about Android internals for me from my first speech. And as I said, when we started, we have some presents for the best questions. I have 4 T-shirts, like my one. I have 4 T-shirts, and we will give them for best questions. Actually, we have 2 questions and 4 T-shirts. Think twice about what questions do you have.
Yeah, and by the way, everything you've seen already lives in production. So
This could be a question. Is it
Okay,
in production?
Okay, so
Yes, it is already answered. No need to ask. And I can answer one more question. Yes, there will be a recording.
so you're gonna get all T-shirts, right?
I will. I will. It's not enough, only one. There are 7 days in the week, as you understand. Okay, if no more question, we can finish. And of course, we have time just for communication, discussion of everything. But we were glad hosting this meetup. Thank you for coming, and I hope we'll see you again. Yeah.
Yeah.
Yeah. Thank you. Thank you very much.
Thank you.